Welcome to Illinois Groundwork. This is an online resource of research and tools to help with the optimization of green stormwater infrastructure design and planning in cities and communities. I'm really happy to introduce you to Dr. Dave Grimley, who is a senior research scientist with the Illinois State Geological Survey. And Dave is going to talk through something called Ksat. Ksat is a measure of the ease with which water moves through a soil or doesn't. And Ksat's a really important value for us to understand when we're planning for green stormwater infrastructure, because the sizing and the siting of green stormwater infrastructure relies on an understanding of that infiltration capacity. And so Dave's going to talk through what is Ksat, how do you measure it, and what are the factors in different types of soils that affect Ksat or this infiltration rate? And then he will also talk about how Ksat is correlated with different soil types and textures, and just briefly show you some maps from our own research to show you how Ksat varied even within one municipality, which would affect the way that you would design green stormwater infrastructure within a community and city. Here's Dave.
Thank you, Mary Pat, for that introduction. I'm going to talk today about hydraulic conductivity in relation to soil texture and other factors in surface soils. So what is saturated hydraulic conductivity? It is the ease at which pores of saturated soil transmit water. And you can make measurements of this either in situ with a musometer, slug test, or other methods, or in the laboratory on a core sample. The in situ measurements are preferred because you consider fractures and other things in the field that you wouldn't otherwise get in a core sample. So the importance of this is for describing water movement through different layers of or horizons of soil. It's useful in agricultural, hydrologic, or environmental purposes, can aid soil and groundwater flow modeling, and of course it strongly affects infiltration rate, which is important for stormwater management and is a key input to green infrastructure. So what different factors control hydraulic conductivity? Soil texture is a big one, whether it's clay, sandy, silty, or mixed, loamy texture. Soil porosity, what the percentage of air or void space is between these solid particles. Soil structure, and bulk density. And all four of those factors control the size and shape of solid particles and voids. So here's an example showing a well-structured soil profile where water can flow easily through it, and a poorly structured, perhaps compacted one where infiltration is going to be reduced due to poor soil structure. So moving on to what really controls those factors in the natural condition, and then later human impacted. So natural controls on those factors would be the geological parent material, whether you have a beach sand, a glacial till, which is common in Illinois, or a clay lake sediment. Here's some photos of sand and silt in the field. And whether that material is loose or dense, for example, whether it was compacted by glacial ice or whether it was deposited in a river may depend how dense that material is. Fracturing is very common due to freeze-thaw cycles or wet and drying cycles and other physical mixing processes. And then there are biological mixing processes which we call bioturbation, due to earthworms, ants, insects, crayfish, or plant roots, or other animals that are burrowing in the soil. This photo shows crayfish burrows that extend a few feet deep in soil of Champaign County, Illinois. And over here is a photo of fractures in glacial till that extend deep into the subsurface. So there are factors other than texture that can control Ksat values. Now, as far as human impacts, a big one is compaction from heavy equipment. during construction of homes or industry, or even farm fields. So a good structured soil has more of an open structure that's good for plant roots. A compacted soil is much more difficult for plants to grow and reduces the infiltration rates. Other factors include addition of fill or removal of native soil profiles, whether the land surface is paved or unpaved, or whether the pavement's permeable or not, changes in the vegetation cover, what type it is, whether you increased or didn't decrease the amount, and changes in soil fauna such as worms, burrowing animals or insects, and whether you've introduced those or whether you've reduced those numbers. So now we have some real world examples of measurements we've taken as part of our project in southern Cook County, Illinois. Fine grain textured materials, clay materials, tend to have very low Ksat values. Mixed texture materials tend to have moderate values, and coarse grained or sandy textured materials from ancient beach ridges have high values. And the variability in here is probably due to some of these other biological and compaction factors that are not accounted for by the texture. And the last slide here is showing you on the map view some of the data of the previous slide, showing you how some of the high Ksat values occurred in these ancient shorelines of Lake Michigan, in these sandy areas, and a lot of the low Ksat values occur in the Calumet-Chicago Lake Plain, which is much more fine-grained material, and including this site too. So that's an example from a paper here, McGuire et al. 2021, if you want to find out more information about it. And finally, a lot of these measurements were made by the emulsimeter method. So if you want to learn more about how the measurements are made, you can look at the other video we have on the emulsimeter itself. So thanks for listening.